Computational rules. 1. Matrix-Scalar Operations. If you multiply, divide, subtract, or add a scalar to a matrix, you do so with every element of the matrix. The image above illustrates this perfectly for multiplication. 2. Matrix vector multiplication. Multiplying a matrix by a vector can be thought of as multiplying each row of the matrix by the column of the vector. The output will be a vector that has the same number of rows as the matrix. The image below shows how this works. To better understand the concept, we will go through the calculation of the second image. To get the first value of the resulting vector, 16, we take the numbers of the vector we want to multiply with the matrix, 1 and 5, and multiply them with the numbers of the first row of the matrix, 1 and 3. This looks like this: 1 * 1 plus 3 * 5 equals 16. We do the same for the values within the second row of the matrix. 4 * 1 plus 0 * 5 equals 4. And again for the third row of the matrix. 2 * 1 plus 1 * 5 equals 7. Here is another example. And here is a kind of cheat sheet. 3. Matrix addition and subtraction. Matrix addition and subtraction is fairly easy and straightforward. The requirement is that the matrices have the same dimensions, and the result is a matrix that has also the same dimensions. You just add or subtract each value of the first matrix with its corresponding value in the second matrix. 4. Matrix multiplication. Multiplying two matrices together isn't that hard either, if you know how to multiply a matrix by a vector. Note that you can only multiply matrices together if the number of the first matrix's columns matches the number of the second matrix's rows. The result will be a matrix with the same number of rows as the first matrix, and the same number of columns as the second matrix. It works as follows. You simply split the second matrix into column vectors, and multiply the first matrix separately by each of these vectors. Then you put the results in a new matrix, without adding them up. The image below explains this step by step. And here is again some kind of cheat sheet. Matrix multiplication properties. Matrix multiplication has several properties that allow us to bundle a lot of computation into one matrix multiplication. We will discuss them one by one below. We will start by explaining these concepts with scalars, and then with matrices because this will give you a better understanding of the process. 1. Not commutative. Scalar multiplication is commutative, but matrix multiplication is not. This means that, when we are multiplying scalars, 7 into 3 is the same as 3 into 7. But when we multiply matrices by each other, A into B isn't the same as B into A2. Associative. Scalar and matrix multiplication are both associative. This means that, the scalar multiplication 3 into 5 into 3 is the same as 3 into 5 into 3, and that the matrix multiplication A into B into C is the same as A into B into C3. Distributive. Scalar and matrix multiplication are also both distributive. This means that 3 into 5 plus 3 is the same as 3 into 5 plus 3 into 3, and that A into B plus C is the same as A into B plus A into C4. Identity matrix. The identity matrix is a special kind of matrix, but first, we need to define what an identity is. The number 1 is an identity because everything you multiply with 1 is equal to itself. Therefore, every matrix that is multiplied by an identity matrix is equal to itself. For example, matrix A times its identity matrix is equal to A. You can spot an identity matrix by the fact that it has 1s along its diagonals and that every other value is 0. It is also a squared matrix, meaning that its number of rows matches its number of columns. We previously discussed that matrix multiplication is not commutative, but there is one exception, namely if we multiply a matrix by an identity matrix. Therefore, the following equation is true. A into I equals I into A equals A. Inverse and transpose. The matrix inverse and the matrix transpose are two special kinds of matrix properties. Again, we will start by discussing how these properties relate to real numbers, and then how they relate to matrices. 1. Inverse. First of all, what is an inverse? A number that is multiplied by its inverse is equal to 1. Note that every number except 0 has an inverse. If you multiply a matrix by its inverse, the result is its identity matrix. The example below shows what the inverse of scalars looks like. But not every matrix has an inverse. You can compute the inverse of a matrix if it is a squared matrix, and if it has an inverse. Why do we need an inverse? Because we can't divide matrices. There is no concept of dividing by a matrix, but we can multiply a matrix by an inverse, which results essentially in the same thing. The image below shows a matrix multiplied by its inverse, which results in a 2 by 2 identity matrix. 2. Transpose. And lastly, we will discuss the matrix transpose property. This is basically the mirror image of a matrix, along a 45-degree axis. It is fairly simple to get the transpose of a matrix. Its first column is the first row of the matrix transpose, and the second column is the second row of the matrix transpose. An M into N matrix is transformed into an N into M matrix. Also, the Aij element of A is equal to the Ag transpose element. The image below illustrates that.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.